This is how Spider-Man suits are properly built in a factory from scratch, with millions of dollars worth of precision engineering. Creative brief kickoff. The design team reviews the specific suit variant, defining performance goals for mobility, durability, and screen accuracy. They align on the visual language to ensure the final product matches the director's vision. Reference archive dive. Designers pull comic panels and film stills to lock down color codes, web geometry, and emblem placement for the digital model. This ensures historical accuracy while adapting to modern manufacturing techniques. Anatomical scanning. A fit model undergoes high-resolution 3D body scanning to capture precise measurements for custom scaling and perfect fit. This data creates a digital twin that accounts for muscle movement during stunts. Mood board finalization. All visual references are compiled into a master digital board, approved by creative leads for consistent aesthetic direction. This serves as the single source of truth for colors, textures, and style. Material mood testing. Early fabric swatches are tested for drape, sheen, and stretch to match the desired on-screen texture and lighting response. This confirms the material looks realistic under studio lights. Budget and timeline lock. Production managers finalize resource allocation, lead times, and milestone deadlines to ensure efficient workflow. This logistical planning keeps the complex production on schedule. Safety and compliance review. All materials and processes are vetted for skin safety, flammability standards, and wearability regulations. This protects the actor from injury or allergic reactions during long shoots. 3D base mesh creation. Artists build a neutral digital mannequin, matching the scan data in specialized modeling software. This clean mesh serves as the foundation for all subsequent digital sculpting work. Suit sculpting. The suit geometry is digitally sculpted over the mesh, including seam lines, panel splits, and web relief details. This defines the muscular silhouette and structural elements of the costume. UV unwrapping. The three-dimensional model is flattened into two-dimensional UV maps to prepare for texture application and pattern export. This technical step ensures patterns wrap around the body without distortion. Web pattern vectorization. The iconic web design is drawn as scalable vector paths for precision printing or embroidery later in production. These vectors are mapped to the body's curvature for a natural look. Color scripting. Hex and RGB values are assigned per panel with alternate layers for lighting variation during day and night scenes. This ensures color consistency across different filming environments. Movement simulation. Physics engines test how fabric stretches and folds during acrobatic poses to preempt fit issues before cutting. This virtual prototyping saves time and reduces material waste. Pattern nesting optimization. Digital patterns are auto-arranged to minimize fabric waste during the automated cutting process. Efficient nesting lowers costs and supports sustainable manufacturing practices. Tech pack generation. A master production document is exported with specs, tolerances, bill of materials, and assembly notes. This guide instructs the factory floor on exactly how to construct each component. Base fabric procurement. Rolls of 4-way stretch performance knit, typically a nylon and spandex blend, are sourced from certified mills. High-quality base fabric is essential for durability and comfort. Reinforcement material order. Lightweight mesh, ripstop lining, and elastic bias tape are ordered for high-stress zones like knees and elbows. These materials prevent tearing in areas prone to friction. Webbing and trim sourcing. Specialty threads, silicone cord, or embroidered webbing tape are acquired for texture, accents, and detailing. These small elements add depth and realism to the overall design. Lens material selection. Optical-grade polycarbonate or flexible TPU is chosen for eyepieces based on clarity and impact resistance. The lenses must allow visibility while reflecting light correctly for cameras. Adhesive and bonding agents, heat-activate films, fabric glue, and seam sealants are prepped for no-sew applications and reinforcement. These agents create strong, flexible bonds that withstand stretching. Color matching lab test. Fabric swatches are dyed or printed to match the approved digital color script under multiple light sources. Lab testing ensures the red and blue hues remain true on camera. Stretch recovery testing. Samples are cycled through hundreds of stretch and release motions to ensure no permanent deformation occurs. This guarantees the suit retains its shape after hours of wear. Moisture and breathability audit. Fabrics are tested for wicking speed and vapor transmission to keep the wearer cool during stunts. Breathable materials prevent heat exhaustion during long shooting days. Pre-shrinked treatment. All textiles undergo controlled washing and drying to eliminate any risk of shrinkage after the suit is built. Pre-shrinking ensures the final fit remains accurate over time. Digital pattern final check. Patterns are reviewed for grain line alignment, seam allowance consistency, and notching marks before cutting. Human verification catches errors that software might miss. Marker making. Patterns are digitally nested into a marker layout for the cutting table to maximize fabric yield and efficiency. This map guides the automated cutting machines precisely. Fabric spreading. Rolls are layered on the cutting table with tension control to prevent distortion during the cutting process. Even layers ensure every cut piece is identical in size. Static elimination. Ionizers neutralize static charge to keep fabric layers from shifting or sticking during automated cutting. This maintains alignment for precise, clean cuts. CNC laser cutting. Automated blades or lasers cut all panels with sub-millimeter precision, sealing edges to prevent fraying. Laser cutting provides smooth, sealed edges on synthetic fabrics. Piece sorting and tagging. Cut panels are grouped by suit section, such as torso, limbs, and mask, and labeled with tracking tags. Organization prevents mix-ups during the assembly phase. Edge inspection. Each cut edge is checked for burrs, melting, or fraying, and any rejects are flagged for recutting. Quality control ensures only perfect pieces move to sewing. Reinforcement panel prep. Knee, elbow, and shoulder inserts are pre-cut from mesh or abrasion-resistant fabric for durability. These inserts protect the actor and reinforce high wear areas. Base panel stitching. Primary fabric panels are temporarily basted together to hold shape before final assembly begins. Basting allows fitters to check alignment before permanent stitching. Web pattern transfer. Vector web designs are printed via sublimation or heat transferred onto individual red and blue panels. Sublimation fuses ink into fibers for lasting, crack-free patterns. Texture enhancement. Raised silicone, puff ink, or embroidery is applied to key web lines for cinematic depth and tactile realism. Textured webs catch light and add three-dimensional detail. Emblem application. The chest and back spider logos are heat-pressed, embroidered, or molded and affixed with industrial adhesive. Precise placement ensures symmetry and visual impact. Ventilation integration. Micro-perforations or mesh inserts are added to underarms and the spine for essential airflow. Ventilation keeps the actor cool during intense physical performance. Lens frame assembly. Eyepieces are molded, polished, and fitted into adjustable tension mounts with hidden hinges. Adjustable lenses allow for expressive squinting without revealing the actor. Closure system prep. Hidden zippers, magnetic seams, or hook and loop anchors are pre-attached to panel edges for seamless wear. Invisible closures maintain the sleek silhouette of the suit. Edge binding and finishing. Raw edges are folded and stitched with color-matched bias tape for a clean, professional interior finish. Binding prevents chafing and reinforces seam integrity. Torso assembly. Front and back torso panels are joined with flat lock seams to reduce bulk and prevent chafing. Flat lock stitching lies flat against the skin for maximum comfort. Limb attachment. Sleeves and legs are aligned and sewn with articulated gussets for full range of motion during stunts. Gussets provide extra fabric at joints for unrestricted movement. Mask construction. The hood is assembled with integrated lens mounts, a neck seal, and breathable inner lining. The mask fits snugly to prevent shifting while allowing breathability. Seam reinforcement. High-stress joints at the shoulders, crotch, and knees are bar-tacked or taped for extra durability. Reinforced seams withstand the forces of falls and swings. Tech pathway integration. Channels for wiring, comms, or cooling tubes are sewn in for advanced technological builds. Hidden pathways support on-set effects without cluttering the exterior. Final closure installation. Zippers, magnets, or quick-release fasteners are fully integrated and tested for smooth operation. Reliable closures ensure quick changes and emergency removal if needed. Full suit fit test. A fit model wears the suit through dynamic movements and any adjustments are marked for alteration. Fit testing ensures the suit moves like a second skin. Stress and stretch audit. Inspectors pull seams, twist fabric, and simulate stunts to verify structural integrity and safety. Stress tests confirm the suit will not fail under pressure. Final press and detailed touch-up. The suit is steamed, loose threads are trimmed, and logos and lenses are polished to showroom standard. Final touches ensure the suit looks pristine on camera. Packaging and documentation. The completed suit is hung on a custom hanger, tagged with care instructions, and logged for delivery. Proper packaging protects the suit until it reaches the set. From raw thread to ready-for-action hero gear, this is the meticulous 50-step process of building